is when I came up with the plan that you've got to check the reporting component first. So if you're working with a fuel tank pressure sensor, which is nothing more than a pressure differential sensor, which means atmospheric on one side, fuel tank on the other side, and the difference is a vacuum, that's what we're using most commonly today, okay? Still being used. On the other side over here was the leak detection pump, and even if you're doing some of the other systems, I have a picture of, there's a switch. The switch is closed, the system is sealed. The switch is open, it's not, okay? So if you take a look, this was a Chrysler DRB3. And on this DRB3, if you take a look on this list, the way they do their testing, this is in sequence. First thing they do is test the switch. That's the reporting component. If the reporting component fails, they're not going to do any of the other tests. Well, you got to take the same approach from the driver's seat. If the reporting component is failing, is not accurate, you look at the number and you even think it's right, you better verify that it works. So the logic there is we can use a sensor, we can use a switch, or some of them did with the DMTLs, Mazda, Bosch used them. Basically what they did is think of this as a compression test. If we can't compress it, we're not going to draw much amperage. That motor is going to freewheel, and because of that, it's going to determine the size of a leak. But if we have any resistance in there because it's building pressure, then that motor is going to slow down, and amperage draw is going to go up, and it's going to know the size of the leak. This is probably the least common out there. This is still the most common, but many systems are using some type of switch to report. So these are the reporting components you need to check. On these two, you need to check first. This one here, this is going to be done as a reference check during its actual test. Okay, so here we go with what I always tell you, and this is just a touch of them, guys. This is just a sample. Whatever product you're working on or products you're working on, know the good numbers. So if I go to Honda and I'm at sea level, I want to see 2.5 volts with the system off, the gas cap off. In this case, most time, even if the gas cap's on, it's vented through the canister, so it's still going to be at 2.5 volts. If I go to the Toyotas, the older Toyotas, the split systems, I want to see 3.3 volts. Now the problem with Toyota is they didn't give you the voltage, so I had to get it with a voltmeter, but I looked at it in millimeters of mercury, and I know 762 is sea level. I know I'm starting out good. This still does not tell me the sensor is working properly. It just tells me that it's reporting at the time in the window I expect. And for early Nissans, they had two generations. They had one that was 3.4 volts at sea level, and they had one that was 4.2. Well, we got kind of a comparison here. If you remember this 4.2, let me back up here a second. What do we see right here on this Nissan? 4.22 volts. So this vehicle is at sea level. It's reporting right now okay, but that does not mean it's seeing the correct vacuum and reporting when it's operational. You have to separate the two. Okay, so now we come over to GM, and the rule of thumb is whatever the midpoint is, up is pressure, down is vacuum. Well, GM flipped two wires in their harness, and they're using the pressure differential the way they used to on the old carbureted cars. When numbers go up, it's a vacuum. When numbers go down, it's a pressure. And their typical would be 1.5 volts at sea level. So you can see this one's in a minute, and I mean really minute vacuum. It's a 1.6 volts. So you have to know good to know bad. Okay? So when you're looking at these cars and you're sitting in that driver's seat, start formulating some good numbers. And I like to do is if you got the Snap-on's a best example, it's recording all the time. Just capture it and save as a movie. When you have time later, go back and look at the numbers you saw. Okay? It's the quickest way to get around it. So understand the car you're working on, how they report leak checks, and what the good numbers are.